Hello students, welcome to this lecture. So in this video we are going to see about the structural units of embedded processors. So what does it mean by the structural units of embedded processor is the units which are being insisted in processor architecture is very much essential for an embedded application. Whenever we are choosing a processor, we will be using and we will be taking into account that structural unit will be very much essential for an application on which we are going to use that particular processor. So on such scenario, we need to know what are the structural units that are very common in all the embedded processors and very peculiar for a given processor. So those kind of processing units are presented here. Here you can notice much blocks are available, and we discuss about those blocks. And before going into that, you need to notice that there are some blocks with black outer lines, and there are some blocks with dotted lines. So those blocks with the thick lines are going to be common for all the microprocessors. But the dotted line boxes are very specific to given processors. So we need to search for those kind of processors, those kind of blocks in a given architecture of the microprocessor to ensure that capability is available for the processor that we need to choose for an embedded system. So here I can abbreviate it one by one so that you can get into the details of this particular diagram. So first one is instruction queue, and I will be explaining it one by one. Instruction queue, instruction register, instruction decode. This is control unit, advanced processing units. This is instruction cache, branch target cache, data cache, prefetch control unit, memory management unit, and this is arithmetic logic unit, floating point unit, atomic operations unit, and this is program counter, and a memory address register, stack pointer, memory data register, and this is supervisory register set. This is supervisory register set, and arithmetic register sets and floating point register sets. So this is bus interface unit, address buses, and data and control buses. So these are all the blocks which are going to be discussed in this particular video. So before going into the details of these particular blocks, we need to notice one thing, that we will be having some control lines to be drawn in this particular diagram. The first one is going to be the control line from this particular memory data register to memory address register and this program counter, and it will be directly connected to the instruction queue. So why this particular connection is available means, this is the memory data register and the memory address register which are used for fetching a particular instruction from the memory. So after fetching this particular instruction, it will be given the address which is given in this particular program counter. So by using this particular address, we will be fetching that particular address of the data using this memory address and memory data registers. So this particular data address will be flown to this particular line, and it will be given to the instruction queue and the instruction registers also. So this process will be taken care by this particular lines, that is the First, it will be fed into this particular instruction queue, and it will be loaded in this particular instruction register, and that instruction will be decoded, and it will be the control signals will be given to this particular control unit. So this is the first line which we need to keep into mind. Second one is the line from the bus interface unit. So this bus interface unit will be interfacing with buses, namely the address bus, data bus, and the control bus, and the decoding logic which is being used for decoding the control signals from the control bus to the control unit to the control bus, and all for all the address and data buses too. So this that is decoding logic will be handled by this particular bus interface unit. The decode logic will be supplied to this particular bus interface unit through the control unit. So the processing of the instruction will be taken care by this particular rows. So afterwards the control signals will be given to this particular bus interface units through this bus only. So this bus is another one important bus. So here you can notice another one thing, that you will be having the bidirectional lines for this particular data register. So in memory data register we will be having the bidirectional supply of the data from this particular memory data register to this particular bus interface unit, and also for the processing of the instruction in the data, the particular data will be supplied by this particular bidirectional line. And also here also you can notice this program counter will be supplied with the particular bidirectional line. And afterwards you can notice another things. So here you can have this particular internal bus to be connected to this particular register sets. So these register sets are supplied with this particular the data in this particular register sets can be in or out, that is the bidirectional data flow will be controlled by this internal bus, and the data which are got are to be written to this particular register sets are supplied from the bus interface unit and from the ALU. So these bidirectional lines will be handling this kind of operations. So afterwards you can notice another one line that is here. That is, this instruction register will be supplying the data to the cache memory. That is, the cache memory is a memory which is placed between the primary memory and the secondary memory. The secondary memory is primarily called as the hard disk, and the primary memory will be our RAM. So the data which is frequently being used are going to be stored in this cache memory only. So we will be having three types of caches. That cache memory will be supplied from the instruction register, and that can be taken from the either from the instruction cache or from the data cache, and in between we will be having the branch target caches too. So these are the main lines which we need to have a concentration on reading these lines. So next we will be going for the description of the each and every units which we have seen in this particular diagram. So the cache data cache means the cache memory as I have just mentioned, that cache memory will be the intermediate memory where we will be storing the data whichever we need frequently. So these data are going to be written into that particular data cache, and that data cache will be dealing with the static variables whichever we are using in our processing, because when we are processing the data we will be having the intermediate results too. So those intermediate results are going to be stored in the static variables. Those static variables are going to be stored in this data cache, and the updation of those particular static variables are going to be supplied to the secondary memory or to the primary memory. So this particular data cache will be working as a write through data cache. So that is going to be an important thing which we need to note down. Next one will be the memory management meeting. So we will be dealing with the virtual memory and the DNA controller concepts in this particular unit itself. So at that time we will be explaining it in more detail. So the floating point processing unit will be dedicated unit for floating point operations. So the floating point register set is also a subset for this particular processing unit, where we need to store the data whichever in the floating point formats. Advanced processing units are very essential for the processes where we need to have a real time in the very fast processing. So these advanced processing units may consist of multi-stage pipeline processing, multi-line superscalar processing, and the map processing. So what are they means? The multi-stage pipeline processing means the pipeline process is a process where we will be segregating the program into multiple lines. So those lines are going to be supplied to the each and every processing line of a particular processing unit. So the first instruction is going to be executed and it's going to be fetch means, and it will be going to be decoding in the execution part, and the second instruction will be fetched in consequence with the first instruction before it is going to be executed. So likewise we will be having three particular instructions to be processed in a single cycle itself. So that is going to be the pipeline process. So you might have studied in the 8086 processor about this pipelining processing. And the superscalar processing is a very important processing unit where we will be having multiple processing units for multiple blocks of instructions. So we can segregate the program around particular task or particular process to be segregated into blocks of instructions. So those blocks of instructions are going to be executed by the superscalar units of a processor, so that you will be having high throughput. Throughput means the instructions which are going to be processed per second is going to be called as the throughput. So that throughput will be very high whenever we are dealing with the superscalar processing units. So the map unit that we have discussed in the digital signal processor topic which we have dealt in the previous video. So the next will be the atomic operation unit. Atomic operation unit is a very important unit for shared data problems. So what do you mean shared data problems means? Whenever we are dealing with a particular program, we will be having some most variables in a particular program. So those variables may be having shared data which may be getting changed in the due course of the program. So we will be having that particular variable to be changed at any time, so that processing will be affected by those particular changing of the variables. So those kind of problems are going to be called as the shared data problems. Those problems can be neglected or can be avoided in the by using this particular atomic processing units. How means we will be having we will be breaking those particular processor instructions into some small amount of programs. Those program instruction sets or the instruction snippets can be executed by the atomic processing unit before interrupt will be occurring. So in the processor there will be frequent of interruptions may be available. So before processing particular interrupt, we need to finish off those particular instructions. So those kind of instructions can be labeled as some atomic operations. So those kind of atomic operations can be processed using these kind of units, so that we will be meeting the hard real-time constraints of a processing unit. So this is how the processors which are having atomic processing unit may be used for the hard real-time systems, or we can use it for the hard real-time constraints. Those kind of embedded systems can be used with these kind of processing units. So next will be the data bus. This you know about this. And the control bus, we will be dealing with the control signals whichever we are going to be giving as an input, and the processing states are going to be taken from this particular control bus only. So this control bus is going to be an important one for any processor. Thus next will be bus interface unit, where we will be having the decoding logic for address and data and the control units. So this decoding logic are going to be evaluated from the very basic 8085 to the very advanced Intel Atom processor. So those kind of interface units are going to be used for interfacing and floating these signals from the ports to the users interface. So for that only we will be using these kind of bus interface units. Instruction register is a register where we are going to store a currently running instruction. So for that only we will be using this instruction register. Instruction decoder is going to be a decoder which is going to decode whatever the instruction is available in this particular instruction register. Next, control unit. So the control unit will be executing this particular decoder instruction, and it will be generating the control signals, and also receiving the control signals from the external sources. Also it will be changing its due codes. Application register set. This is a register set where the very high sophisticated microprocessors are supplied with these kind of register sets, where we will be having the application oriented registers where our application status and the application controls can be controlled by this particular register set. So for that only we will be using this application register set. Arithmetic logic unit, where we execute the given instruction, and the program counter, where this is the counter where we will be having the next instruction which is going to be executed by the processor. So this particular program counter will be displaying the address of the instruction which is going to be executed in the next cycle. So so this particular program counter will be supplying that particular address of that particular instruction to be fetched from the memory. That is going to be very faster in nature. So for that only we will be using this particular program counter. Next we will be seeing about the SRS, that is the system register set. In the ARM and the high-end processors will be having some supervisory mode of operation. So in this supervisory mode of operations, we will be having the privileges for the usage of the real-time operating systems and some system related and configuration related operations. So for that operations, so if you program those operations, we can control the whole systems from that particular processor itself. So for that only we will be using this kind of system register sets. So using these system register sets, we can control the whole processors and the whole embedded systems. Stack pointer, where we are using this particular pointer is that the pointing of the stack where that particular data is being stored inside the stack. So stack is mainly used in the interrupt processing. So whenever an interrupt occurs, that at the time of interrupt, the status of all the registers which are important for a particular microprocessor's operation will be stored in the stack. So for storing of the stack and also the retrieving of those data which are stored in the stack can be retrieved using the stack pointer. So by incrementing or decrementing the stack pointer, we can control that interrupt processing. So for that only we will be using this stack pointer. Instruction queue is a main thing where we are going to use the pipeline processes and also the superscalar processing units. So using this instruction queue will be a first in first out instruction queue. So where we will be fetching those instructions which are going to be executed or to be queued in the FIFO queue, that is instruction queue. Next we will be using the prefetch control unit. So combining the instruction queue and the prefetch control unit, the instruction queue will be having the instructions to be executed. So this instruction queue is to be supplied with using this prefetch control unit, because this control unit will be fetching those instructions to be executed from the memory, and this control unit after fetching those instructions from the memory, it will be storing into this particular instruction queue. So afterwards, the instruction cache is going to execute this is going to take those particular instruction queue, and upon those instructions, that instruction and the programs are going to be supplied from this particular instruction cache only. So by using these three processing units, so we cannot neglect any one another. So using these three control that is processing units, we can achieve a very great speed in a particular processor's performance. So for that only we will be using this kind of three processing units in the high-end processors. So next we will be going to see about the branch target cache. Branch target cache is an special cache memory which is going to be used for the branching instructions. So if you are going to have a very frequent interrupting systems, so in those systems, if you are having those particular systems with jump operations, so the target of the jumps can be stored inside this cache memory, so that we can save the particular processing speeds, and we can also save the time cycles of fetching the data which are going to be the target of the jump instructions from the memory. So instead of fetching the data from the memory, we will be prefetching those particular data from the memory into this particular branch target cache, so that we can have the access of those data to be very fast manner. So for that only we will be using this particular branch target caches. So that's all about this. Thank you.